10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hi, my name is Matt Welker, and I'm a member of the support, training, and demonstration team for Electrogig. The animations and stills you just saw were created using Electrogig's 3D Go, a high-end, solid modeling, ray tracing, and animation package for Silicon Graphics and Sun Microsystems workstations. Some of the things I like to stress in my demos are the extremely high image quality and the extreme ease of use. The unique combination of solid modeling and ray tracing provides for superb photorealistic images. And the interface was designed by designers to be highly intuitive and easy to learn. It really makes the support side of my job easy when such a high-level package is this easy to learn. So let's take a look at what 3D Go can do for you. Okay, here you see the 3D Go interface. What we have are 3 modeling windows, and then in the lower left-hand quadrant we have the menu. Okay, if you look in the lower left-hand quadrant here, we have the main menu buttons. By clicking any of these, you reveal different submenus. All the menus are color-coded and the buttons are consistently placed. For instance, you see we have purple buttons that involve file saving and retrieving. If I had an attribute that I wanted to save or retrieve, I could go to Attributes and I would look for the purple buttons, and that's where you know where to look for it. It's the same with your solid objects. They're always purple, they're always there. You can see the animation button down here is yellow. If I want to animate a transformation of an object, the buttons are yellow. Once again, if I want to animate an attribute, they're yellow. Animate a light, yellow. Also, the Move button for my lights is here. The Move button for my objects is in the same place. The Move button for my camera is in the same place. This color coding and consistent placing of buttons really helps lower and reduce the learning curve. The repetitive motions that are involved with modeling and animating just keep reinforcing what you're learning. Okay, what we have are a couple different ways for you to look at your models. I'm going to size just this ball up real quick. Now what I can do is on my keyboard I'm hitting a K, and that gives me a ray sketch. That's just a quick preview of what you've got here. If I hit T, I've got a true ray trace right here. You can also flat shade these, so I can go in here and rotate this a little bit if you like to model flat shaded. I can also model in a one window view if I like that. Personally, I prefer the 3-window view. Okay, so this is how the interface is designed to make it quick and easy to learn. The first thing I'm going to show you is just primitive modeling. We're going to use this ball right here. I'm going to size it up and show you how, using solid models, you can perform true Boolean functions. I'm going to subtract a cylinder, and in my side window, I'm going to transform the cylinder. It's black, it's active. I'm going to size it up a little bit. Then just in the local X of this window, I'm going to XYZ size that. So what I've done is I've subtracted this cylinder from this ball. In my front view, I'll do a quick sketch. You can see how that works. If I want to ray trace that, I hit T on the keyboard, and you can see what it looks like ray traced. Now, if you don't like to see what your subtracted object looks like and you want to see a truer representation, highlight that. What we're going to do is evaluate it. You can see how that works. If I want to, I can flat shade that, rotate it. So that gives you an idea how it looks. Okay, go back to wireframe. You can animate that really simply. What we're going to do here is animate. I'm going to go up the tree to the right. Now I've activated my subtraction here. So what I'm going to first do is I want to fix the event. Okay, it tells me that I need a name for my subtraction. I'm going to call it the whole and fix it at frame 25. So now when I move this to here, I can fix that event at frame number 1. So at frame 1, here's what my ball looks like. If I then go to frame 12, this is what it looks like. Frame 18, and finally at frame 25, I've got a hole all the way through. So you can animate these Boolean functions, a real advantage to using solids. I'm going to show you a little more complex example. I'm going to get a solid we have here called camera. It's a camera lens that we've created using just the primitives. You can model in at least 5 different ways in Gig. We have solid primitives. We have freeforms for rotations and extrusions. There are Sculptor, which is like metaballs, except you can use any primitives. There's a NURBS modeler. What we're first going to do here is look at our hierarchical tree. You can see down this side we have the camera lens, and over on the right-hand side of the tree we have something called the knife. I'm going to activate my knife, and I'm going to change the relationship from a grouping to an intersection so that my lens and camera, or my camera lens and the knife need to intersect. Okay, my visibility I'm going to make total, skip right past it, and then I'm going to move the knife down. So only where the camera lens and the knife are intersecting will they be visible. Here's a quick sketch of it. Now I'll just do a trace. So you can see here, this is one of the advantages of solid modeling, as you know, opposed to like polygonal surface modeling. We didn't have to destroy the original object to create the intersection. No internal surfaces were rebuilt. We still have the object intact. What this means is I can animate these. I can also, I'll size this down. Another sketch, I'll do a ray trace of this. There you can see a slice of the camera lens. All right, what I can also do, move this. I'm going to multiply, move it down here, multiply it by 5, in between the first and the second, yes. Orbit my camera around a little bit so you can see the slices, and do a ray trace. Once again, you can see that we didn't have to destroy the original model. It remains intact, and no internal surfaces were rebuilt. So we can at any time go in and edit this camera lens or animate any part of it. Okay, I'm going to reset this real quick. What I'm now going to do is show you a little flip book of that. You can see how we've animated a Boolean. It's an animated intersection. So once your model is built, it's very easy to animate. All right. Okay, the next thing I would like to show you is a freeform modeler. Down here you see freeform extrusion, freeform rotation, and freeform patch. Okay, what I'm going to demonstrate right now is just a freeform rotation. I click on that. I can go into freeform grids. I'm going to show the y-axis. So you can see we have a default circle being rotated around the y-axis, and it gives us the default torus. First thing I'm going to do is remove the default shape. I'm going to use an open path, and I'm going to add some points. Okay, I click it once, and I place it. My middle mouse button I can use to move it, and click the left mouse button again, and I set it. Now after I get 3 points set, you'll see on the right-hand side how I start to get the shape to come out. You can see how intuitive this is, how quick and easy it is to make something like this. Now if I place 2 points right on top of each other, I can get a sharp line rather than a curve. All right. Here we have a glass. Going to size that up, orbit around it a little bit, and do a ray trace. Okay, that's how easy it is to make something like this. You can see it's just gray. It has its default colors. What we're going to do is play around with the attributes a little bit, get into some of the basic attributes. What I'm going to do first is I'm going to go to Solid Construct, and I'm going to group a cube in this top window. It's actually the bottom right-hand window. It's my top view. I'm going to size this up. Okay. Then up here in Camera 1, I'm going to say no perspective to give me a flat view. At that point, I can move my tabletop down, put it precisely underneath it. Next, I'm going to make a copy of the tabletop. I'm going to rotate it 90 degrees. And then I'm going to move it back to here. Okay, now I'll go up my tree, and I'll go to the right and just get the back wall and the table I've made. In my top view, I'm going to size these just on the X so that they're a little bigger. Now if I do a quick sketch of that, you can see basically what I have. Alright, now what we're going to do first is we're going to go right and we're going to take our back wall. First thing we're going to look at here, we go to Attributes. The back wall is active. What we're going to do is right here we have a button called Materials. With that we have many predefined materials. Diffuse are just colors. Materials are for stones, wood, and metals. The special, this one is patterns, so we could put a pattern on of some sort, or we could go to the mixed. We're going to take a mixed pattern for the back wall. Let's try something like this. So our back wall looks like that right now. Now what we're going to do is we're going to take the floor. Now another way to do attributes is to simply combine what we have here. We're going to make, let's see, what do I have? Floor. All right, we're going to add some color, and I can click in this box, type blue, and it gives me blue. What I could also do is click in this box right here where the blue color is showing, and I get CMY sliders, RGB, or HSV. You can also put numbers in here if you like. So it's however you like to work with color. You have your choice. I'm going to take that color, and I'm going to make it, let's say, 80% of its color, and I'm going to add some transparency. No, let's not add that transparency. I'm going to add reflectivity. Make it 20% reflective. I'll do a quick sketch. You can see things are starting to reflect down here in the floor. If I do a trace, we'll get an idea what this looks like. Okay, the next thing we want to do is make our goblet look like it's made of glass. Very easy to do. We simply go all the way up the tree and to the left, and we have it highlighted. Now what we have to do is add glass. You have different factors here, your reflection factor, your refractive index, the color, the transparency color. Say we don't know what to make our refractive index. We simply click the Help button, and we click on refractive index, and it gives us an idea of what we need. It says here that examples are 1.00 for air, 1.33 for water, 1.52 for crown glass, and so on. What I'm going to do is just click in here and type we'll use 4.4 today. I'm also going to add a little bit of specular to make it shiny. We'll make it specular about 50. I'm going to move the camera back around a little bit. Okay, here's what we have right now. Move up just a little bit. There we are. Do a quick ray trace of this and you'll get to see how the glass looks. So here you can see how easy it is to work with the attributes. We have pre-made materials that you can apply, or you can simply combine some of the attributes that are very simple and easy to work with. Here you can see how glass works. With a true ray tracer and solid models like you have in Electrogig, you get very true reflection and refraction. This is because you're calculating the ray of light through a solid rather than other modelers that actually just calculate surfaces. It's really difficult to get a true glass effect. But this is how it works in nature. Okay, there you can see the rendering of our glass. The last thing we're going to look at are advanced attributes. For instance, if we had a cube here, what we can do, size that up. Okay, what I'm going to do is put a color on it. I can go to the map factory for my colors. What map factory is a 2D, 3D map compositor. So I'm going to take my marbles and brick library and say my plaids. Let's do that one. Let's do that one. You can multiply these together to get some very interesting sorts of materials. I could take that then to the left side, get some clouds, make my clouds 60%, my new pattern 40%, and I could add them together to give this sort of an effect. If I didn't like that, I could switch them, add them together. So there are a lot of different combinations. You can save your maps and put them in here and use different maps. So there's basically what it looks like if we do a sketch. Okay, here you see the ray traced version of this. You can see how we've combined different maps to get this, how we've combined a plaid with the marble and then added that to our clouds. You can also use Map Factory for intensity maps. For instance, if I had a red and black and I wanted to use a Map Factory intensity map, I get a different library. I can use something like this and create unique intensities to get that sort of a map. Let's increase these, multiply those. So you can do that sort of a thing. And here's a ray tracing of that intensity map. All right. Right here is our sculptor. We're just going to start out very simply. We're going to take a couple balls. We're going to start with one sculpted ball and union it to another sculpted ball. Move that one over. Up the tree, size them both, move them both. Sculptor is a density modeler. So what we have here are two different balls, and what they have is a density of 2 at the center, at 1 at the edge, and then they have a range that tapers off to 0. Wherever their ranges overlap, and the result is 1 or higher, it is visible. What we're going to do here is show you the ranges real quick. You can see how these ranges overlap here, and where they equal 1 or higher, it's visible. Okay, what I'm now going to do, let me go back here, edit my sculpt, shut my ranges off. I'm going to take one of these and I'm going to make it red. And then I'm going to go up here and make this one blue. And I'm also going to add some specular of 30. Okay, so here's what we have right now. When I go in here to edit these, I'll highlight them both, I can evaluate them. Gives me an idea of what they're going to look like. I'm using a Silicon Graphics Indie right now, so I don't have any benefits of hardware graphics engines. So I'm going to go to one window to speed this up a little bit, go right, and I'm going to move the right ball around. I simply selected that by hitting R on my keyboard. It picked the right object in my hierarchical tree. So you can see how this is going to react. Okay, next thing I'm going to do, I'm going to shut my evaluation off. And I'm going to go out of here, and I'm going to go to my view tree. I'm going to view my tree. What I can do is change one of these. I'm going to change this ball to a torus. I'm going to go back into my edit sculpt. I'm going to reevaluate these. One window, flat shade, right, move this around. So you can see how you can create good organic shapes using this. Okay, once again, if I go to wireframe, I'm going to make a little sub window right up here. And I'm going to trace that real quick. Okay, you can see how the attributes are not blending. If you want, you can blend from one object into the other, or you can blend them both together. I have them both highlighted, so what I'm going to do is I'm going to click down here where it says attributes not mixed. It says, do I want to mix the attributes down the subtree? And I say yes. Now when I do a ray trace, what you're going to see is that the attributes actually blend. Not only does the color blend, but you also get a blending of your specularity here. I've got a couple examples here. Show some of these images how not only can you blend those attributes, but you can also blend transparency. You can see over here on the right hand side how the bump map blends with the red and white pattern. Okay, another example here. You can see how bump maps and transparencies blend together. This is a very powerful feature and very unique to 3D Go. Here you can see all the different primitives that you can use. The next thing I would like to show now is how you can model using NURBS. This is the NURB modeling interface. Right here we have our model. If you're not familiar with NURBS, NURBS are non-uniform rational B-splines. With a NURB, you can add a control point anywhere along here. We're going to add some points without changing the shape of the curve. So I've added some control points to give myself some more control. Now if I want, before I set those, I can use my middle mouse button to move them. In this window, I'm going to update my windows so that when I move these points, you'll see it in real time, how it reacts. This is a very strong and powerful feature. With this, it makes your modeling very easy. Another thing we can do here, oops, let's do all three windows. I'm going to go to primitives, and I'm going to delete this primitive. Now what I want to do is make a sketch. So here, I'm going to sketch this. And here's what I have. I can flat shade that, rotate my camera around. You can see what I've got here. I can also edit the surface so that at any point, if I want to just move particular points, you can see how that works. Once again, I don't have the benefit of any hardware graphics engines, but you can still see how this operates in near real time. So with that, you know, I could work in any place in here. What I'm going to do is show you something unique to this. I'm going to save my model. I'm going to call it model number 1, mod 1. Okay, what I'm going to do here is I can, with 3D Go's NURBS modeler, you can do point independent morphing. What I want to do now is make a sweep. What a sweep is this contour down this spine. The contour here on the left-hand side, the spine in the upper right. What I'm going to do here is first move some points, and then I'm going to go to primitives, and I'm going to connect these. I'm going to go back to point. I'm going to size up my spine. Okay. Then what I'm going to do is edit the twist. I'm going to move some points here. You can see how that affects this. Okay, now I've got this. I'm going to save this model as MOD2, Model 2. Now what I can do here is fix this NURB, fix the model on frame 1, go to Animation, get Fix NURB, Mod 1, and fix that at frame 25. So what I'm going to do now is play that for you. What I've achieved here is point-independent morphing. With this, any NURB can morph into any other NURB. You can bring files in here, EPS files, bring them in as text, and you can have anybody's logo morphing to anything you can create in NURBS. It's a very powerful feature. So that's how the NURBS modeler works. The next thing I'd like to show you is 3D Go's particles. Okay, what we do here is we go to Tools, Particles. Here you see the 3D Go Particles interface. Now what we have here is a hollow NURB tube, and then we have a base down here at the bottom. These two have been made a collision tag. Base is our collision tag. You can see that it's orange. If I begin the simulation, you can see I have an invisible point up above that's emitting particles. Well, the first thing I'm going to do here, once again, I hate to remind you that I'm using an Indy, and I just want to speed up my simulation a little bit. Go to one window. You can see what I have happening here. Okay, now I have many different variables here that I can work with. For instance, gravity. If I want to, I could make this -6. And you see immediately in real time how the gravity changes to a negative gravity. So these things start moving back up the tube or back up. You can see they're being emitted and then moving up immediately. I can change this back to a positive. I also have other features. I have, for instance, friction. And I have, let's go down here and get the resilience. Okay, with the friction, it's set at 0.18 now. If I made friction 0.9, for instance, you would see how slowly they go down the tube. They're like stuck on it. Move this back to 0.15, and they move a lot faster. Now if I change my resilience, let's say to 0.9, you can see how they immediately start bouncing a little higher. Okay, we can change that back really quickly. 0.3. 0.1, so they're almost dead when they bounce. Okay, so that's how the collision tags work. What we're going to do next is get a different one. We're going to get, let's get an animation here. How about the candle? Now, when I go to particles, what I'm going to do here is I'm going to begin my simulation. What I have is an emitter emitting particles, and up above there's a little X moving back and forth. This is a field, so what I need to do is connect my particles to the field. First thing I'm going to do, though, is go for my start speed, and I'm going to slow my start speed down to 0.8. You can see immediately how that affects the speed of the particles as they're being emitted. Next, I'm going to attach my sync field as a fluid type of field. Confirm that. You can see how the particles are being drawn up towards it. Get my field tag, the sync, and I can control the power and the gradation. The gradation is how far away from the point the fall off is. It's set at 0.2 now. If I did 0, for instance, you can see that the fall off is constant. No matter how far away from the point the particles are, there's a constant amount of pull. If I put it at 1, for instance, you'll see that the fall off is very near the center of the cross, so that hardly any influence is exerted over the particles. Set it back to 0.2, and you can see how this is pulling the particles back up towards the sync field. Now any of these fields, any of these powers, or any of the dynamic controls can be animated. You can create time curves for those and edit those time curves. So this is how you would create realistic looking flame. The next thing I would like to show you is another animation. It concerns how you can create organic looking natural objects using particles. What I'm going to do here is go back to particles. I'm going to turn on my animation camera, and then I want to begin the simulation. Now immediately you can see that particles are being emitted from the bottom. Now the emitters are being squeezed in and out. What I'm first going to do is connect my particles. Now you can see how I have a smooth flow, and I'm going to show the radius. I've got different fields here. One is an ejection field pushing the particles downward, and I also have a noise field that's moving the particles to give them a rather random, natural looking motion. All right. Okay, the next thing I want to do is show you some flipbooks of that. Play that. Okay, you can see how the flame is moving back and forth with the field. We've also got a spotlight attached to the field to give the shadow down at the bottom. You can see how the colors are changing in the particles. We simply attached a curve, a map curve, to the color of the particles so that it would change over time. Play that. Here you can see how the jellyfish is working. The plants you can also see are made of particles, connected particles, and little fish in the background were made of particles. So simply by creating particles and putting some fields in, you get very organic looking shapes and animations. So in this sense, it's another form of modeling. Okay, the next thing I would like to show you is some simple animation techniques. Let's take this ball, for example. What we're going to do is we're going to name it ball. And then we're going to group a cube. We're going to size it up a little bit. In that window, we're going to use no perspective. And we're going to move it down a little bit, and we're going to call that table. Okay, so what we're going to do now is get our ball, and we're going to move it. We're going to fix the event. We're going to make that frame number 1. We're also going to fix the event at frame number 50. And then we're going to move the ball to right here and fix the event at frame number 25. Okay, so now when we go to animation, we'll play that. You can see what the ball's looking like. Okay, it's not a very realistic looking bounce. So what we're going to do is we're going to change its time curve a little bit. I'll play that again for you so you get an idea what's going on. Okay, this light green stripe here says trans ball. They're the transformation curves for the ball. If I expand this, you can see I have different time curves corresponding to the position, rotation, scale, and skew of the ball. What I'm interested in is the Y position of my ball. So I'm going to show the time curve of that, and here's what it looks like. What I need to do is edit the ease in and ease out. I can simply do that by showing the ease in, ease out, and moving them up. So when I play that, the bounce is much more realistic. Very simple way to create animations. Another easy way to create animations is like this. If I take this ball and I move it up here, multiply it, move it over here, make 3 of them in between the first and the second. What I want to do now is name them, auto tag. We're going to call it ball. So what that's done is named all my balls, ball 1, ball 2, and ball 3. Now what I'm going to first do is get solid tag. We'll take ball 1 and we'll fix an event here. So ball 1 is there at frame number 1. Now by turning on my keyboard and rotating it on the Z-axis, negative 180 degrees, fixing that event at frame 25. Then I'm going to move it, fix the event there at frame number 50. If I now play this, you'll see what happens with the one ball. Okay, I like that animation, and I want to give that animation to the other 2 balls. So what I can do is go into my tree. I can edit the animation. I simply copy the animation from this, and then I paste it to that ball, paste it to that ball. So when I now play this, here's what I have. Now if I want things to change a little bit, I can move ball number 2 into the future a little bit so it doesn't start so soon, and ball 3 even farther. So what I would have is this. Or if I wanted them to take less time, I could stretch any of them. Very easy and intuitive. You can also create paths. If you want, you could create something like this. We'll transform this up a little bit. Let's do that differently. What you can do, once again, we'll size that in the top window to get it like this. No perspective. We're going to group a cylinder. And then we'll move that over here. Okay, what we do is we go to animation. We say new track, make some track points. Add a point at frame 0, put it here, add a point there, add a point there, add a point there, add a point there. That should do it for right now. So what we're going to do here, first we're going to save the track. We're going to call it track, overwrite the old track that was there. And we're going to put our center of interest on the track. So now what we have is our center of interest follows that track. Okay, what we can also do is get a new track. We'll get the same track and we'll put our camera on it. All right, so if we go to a side view, we go into the track points, set all the points, move it up, size it, that's what we get. So you can see how easy it is to build a track and the sort of things you can do with it. As you've just seen, 3DGo is extremely powerful and easy to use. The high-end modeling, ray tracing, and animation features are accessible to even those new at animation. And the power and breadth of the program provide details that even the most experienced power users demand. If you have any questions concerning 3DGo or any of the Electrogig products, or would like any help locating a dealer near you, please feel free to give us a call. Thanks very much.
We are the future.